going to cover 1.3, which is going to cover powers of monomials. So it says, I can use the power of a power property and the power of a product property to simplify expressions with integer exponents. So when we're looking at this, we have two vocabulary words. So the first one says, to find the power of a power, multiply the exponents. So they're kind of already telling you what it is. It's the power of a power rule. So the next one says, to find the power of a product, find the power of each factor and multiply. So that is power of a product rule. So here it says learn. Simplify 6 to the 4th power cubed. So when we talk about exponents, they tell you how many times to write things. So here with our exponent of 3, it's telling us to write 6 to the 4th 3 times. But then all 3 of these have a power of 4, which means I would need to write each of those 6 times, or 4 times, sorry. So I'd have 6, 6, 6, 6 for the first 4. I have my second 4, my third 4. So then to figure out the answer, I can count how many 6s there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer would be 6 to the 12th. So if I look at my original exponents of 4 and 3, the way to get 4 and 3 to become 12 is 4 times 3. So that's how they came up with, when you have a power to a power, you'll multiply your exponents. So here, to find the power of a power, we multiply exponents. So they're going to have us practice that in these next few. So we have 8 to the 6th cubed. So if we follow that rule, we should be multiplying our exponents. So 6 times 3. If I take 6 times 3, that's going to get me 18. So the answer there would be 8 to the 18th. So then if I do the 6th, or 6 cubed to the 5th, we multiply our exponents. So we're going to be taking 3 times 5. Well, 3 times 5 is going to get us 15. So we would get that this is 6 to the 15th. Next we have k, and we have that it's to the 7th and 5th. So we go ahead and multiply our exponents. So I'm going to take k, and it'd be to the 7 times 5. Well, 7 times 5 is 35. So this would be k to the 35th. Next we have x, that's to the 4th raised to the 7th. So we go to multiply our exponents. So we have x to the 4th times 7. 4 times 7 is 28. So x to the 28th would be the answer. So now we're going to do power of a product. So it's power of a product because inside these parentheses where we have this power of 3 here, they're multiplying these things that are inside. So it says expand. So we're going to kind of do the same thing that we just did. I'm going to write 4a squared a total of 3 times. Then it says commutative property, which is the property that allows us to flip things around multiplication. So I'm going to bring all my numbers out front. So 4 times 4 times 4. And send all my a's to the back. So we'll have 3 of those. So then it says simplify powers. So if I look at this, there are 3 4s, so 4 to the 3rd. And then there are 3 a squareds. So a squared to the 3rd. Then it says simplify. power of a property, or power of a power property. So we have 4 to the third again. And then if I look, I would multiply 2 and 3, which gives us a to the 6th. So it says, notice each factor inside the parentheses is raised to the blank power. So if we look here, 4 and a squared were both raised to the power of 3. So they're both raised to the third power. So what that's trying to get you to realize is when you have these exponents on the outside like 3, you're going to apply it to everything that is on the inside. So we applied it to the 4, then we applied it to the a squared. So that's what we're going to be practicing in those next few examples. So here we have 2x to the 4th to the 4th. So we have to take this 4, apply it to the 2, so 2 to the 4th, and then we got to take it and apply it to x to the 4th. So of x to the 4th raised to the 4th. We'll go ahead and simplify this. So 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And then we multiply our exponents for power of a power. So if I take 4 times 4, that's going to get us 16. So this would be 16 x to the 16th. So we're going to go ahead and practice that with this next one as well. So we have cubed, and we got to distribute that to everything on the inside here. So we're going to have 7 cubed, and then we'll also have w to the 7th being cubed. Okay? So when I look at my w, since it's a power to a power, we have to multiply. So if we go to multiply these, we're going to be taking 7 times 3, which is 21. So then we would take 7 times 7, which is 49, times that third 7, which is 343. So we would write that with w to the 21st. Now we can apply the next one of power of 4. We distribute that to both things. So we'll have 2 to the 4th, which we've already done is 16. Then we have p cubed being raised to the 4th. So since it's a power to a power, we multiply. So we have 3 times 4. 3 times 4 is 12. So this will get us p to the 12th. So we'll go ahead and go to our next page of the notes. So this page, there's not much left to do. So we'll go ahead and get started. So they add an extra thing. So in the last few examples we did, we had 2 things inside our parentheses. Now we have 3. So we want to take this 5, apply it to the negative 2, the m to the 7th, and the n to the 6th. So we'll have negative 2 to the 5th. We'll have m to the 7th being raised to the 5th. And then we'll have our n to the 6th being raised to the 5th. So negative 2 times negative 2 is 4. Times negative 2 is negative 8. Times negative 2 is 16. Times the negative 2 is negative 32. For our m here, we have to multiply our exponents, so 7 times 5. Well, 7 times 5 is 35, so this will be m to the 35th. Then we're going to do the same thing for our n. We have it raised to the 6th, then being raised to the 5th, so we multiply 6 and 5, which will get us 30. So this would be n to the 30th. So once we've simplified, that's going to be what our answer is. So in the next one, we have this raised to a power of 3. So we're going to go ahead and apply this 3 throughout. So we're going to have negative 5 raised to the 3rd. Then we'll have w squared also being raised to the 3rd. and then x to the 8th being raised to the 3rd. So negative 5 times negative 5 is positive 25, times another negative 5 is going to get us a negative 125. So negative 125. For our w, we have that it's squared and then being cubed. So we have a power to a power. So we want to multiply those. So we take 2 times 3. Well, 2 times 3 is 6. So we have w to the 6th. Then our x is being raised to the 8th, then to the 3rd. So we have to then multiply those. 8 times 3 is going to get us 24. So this would be x to the 24th. So that is the final answer for that one. Now we can go ahead for this last example that looks like this and apply this square. So we're going to distribute this square throughout. So we're going to take 4 squared. Then we have to take x to the 6th squared. And then y to the 7th squared. 4 times 4 is going to get us 16. X to the 6th being squared. We multiply those exponents, so 6 times 2. That'll get us x to the 12th. Then for our y, we're taking 7 times 2, because it's a power to a power, which will get us 14. So this will be y to the 14th. Now this last one can be a little bit complicated just because it's a word problem. So we will draw a little bit to help us. So we have a square floor. So I'm just going to kind of sketch my square floor, put an F. Then we have little square tiles that we're going to be talking about. So the length of our square floor is 8x cubed y squared. The nice thing about a square is the length and width are the same. For the tile, our length and width are xy. So these are the same. So it wants to know how many tiles it'll take to cover the floor. So first, we're going to figure out the total area of the floor. So since it's a square, it's the side squared. So we would be taking 8x cubed y squared and squaring it. So we apply that square to everything. So we have 8 squared, x cubed squared, and y squared being squared. 8 squared will be 64. We multiply exponents, so 3 times 2 is 6, so x to the 6th. Our y has a 2 and a 2, so 2 times 2 is 4. So we got that is the area of the floor. So then we need to figure out the area of one tile. So it's a square, so we can take our length and square it. So we apply that to both things. So x squared, y squared. So remember, there's no exponent here, so it's a 1. Once you know the area of the whole floor and the area of the tiles, you would want to divide them to figure out how many tiles you can fit. So we're going to be taking 64 x to the 6th, y to the 4th, divided by x squared, y squared. So there's no number technically, so there's a 1 here. 64 divided by 1 is 64. When we divide, we subtract the exponents. So for our x, the numerator was 6, denominator was 2. So that would get me x to the 4th. For my y, the numerator is 4, denominator is 2. So I take 4 minus 2, which would get me y squared. So this would be how many tiles we would need to fill up that area.